Uma universidade conectada com o seu tempo, com a ciência e com a formação humana. A Universidade de Caxias do Sul é uma universidade comunitária que tem como missão produzir, sistematizar e socializar o conhecimento com qualidade e relevância para o desenvolvimento sustentável. Conectada com você, sua vida e seus sonhos. Cerca de 100.000 pessoas levam no seu currículo o nome da Universidade de Caxias do Sul. Mas o legado de uma universidade não pode ser só medido pelo número de pessoas que ela formou, mas também pelos conceitos e ideias que ela ajudou a revolucionar, pelas empresas que ajudou a implantar e até mesmo pelos sonhos que ela ajudou a concretizar. A marca da UCS ultrapassou as barreiras do tempo e os limites do espaço. Ela está impressa em milhares de histórias e conquistas e segue sua trajetória de sucesso, preparando pessoas com capacidade para transformar o mundo, criar o novo e antecipar o futuro. Universidade de Caxias do Sul.
Bom, pessoal, boa noite. Bem-vindos, bem-vindas ao Darwin Day do Museu de Ciências Naturais da Universidade de Caxias do Sul. A gente tem hoje a honra de estar com Máximo Pigliucci, biólogo evolutivo, filósofo. Máximo é professor do City College de Nova York e tem uma extensa literatura publicada em biologia evolutiva, em ciência, em filosofia da ciência e em filosofia também. Ultimamente, o Máximo tem publicado temas relacionados ao estoicismo, à filosofia estoica. E entre os livros dele estão How to be Stoic, A Handbook for New Stoics, e esse é o último, The Quest for Character. Mas não são esses os assuntos que o Máximo vai discutir conosco hoje. Máximo Pigliucci escreveu várias coisas sobre biologia evolutiva, filosofia da ciência, entre elas Nonsense on Stilts, uns ótimos livros sobre filosofia da ciência e pseudociência também, como distinguir Ciência de Bobagem, subtítulo do livro. A Filosofia da Pseudociência, uma coletânea de capítulos extraordinários sobre o que difere a ciência da pseudociência, que é inclusive um dos temas da conversa de hoje. E também Science Unlimited, que é uma discussão sobre, uma coletânea também de capítulos sobre os desafios do cientificismo e os limites da ciência. A palestra vai ser realizada em inglês e depois de cada slide eu vou fazer uma síntese daquilo que o professor Máximo Pirucci vai falar. Então, quaisquer eventuais problemas na tradução, eles ficam por minha conta. Máximo, thank you for being with us. It's a pleasure, an honor to have you here. Thank you for accepting the invitation. And let's start, please.
Thanks for having me. It's a pleasure. So the way we're going to do this, then I'm going to present a slide, then I'm going to stop at the end of the slide before moving to the next one. You're going to make a little bit of a summary. So let's see here if I can get to the first slide. That's just the title, so there's not much to translate there. So what I want to do today is to talk a little bit about the science behind evolution, since this is Darwin Day, and after all, we're celebrating the origin, basically, of evolutionary theory. And then, however, I want to discuss in the second part of the talk the pseudoscience of evolution. That is, when is it that people misunderstand evolution, that they have religious or ideological biases against it. And then we'll compare science and pseudoscience in a broader context by the end of the talk. So let me start with the very basic idea behind the Darwin-Wallace theory of evolution. The one on the left is, of course, Charles Darwin, a very young Charles Darwin. And the one on the right is Wallace, the co-discoverer, Alfred Russel Wallace, the co-discoverer of natural selection. Basically, the idea that these two came up with is that the history of biology on planet Earth can be explained adequately by the interaction between three different things. Heredity, this being the idea that the offspring of certain organisms inherit the trait or similar traits to those of their parents. That there is variation in the population, that is, individuals look differently from each other and they have therefore differences in different traits that make a difference for survival. And then natural selection. Natural selection is going to sift the variation that is available in any particular generation, so that certain variants, let's say animals that run faster or fly better or whatever it is, have a tendency to survive and, of course, therefore to transmit through the next round of heredity their characteristics to their offspring, and the process keeps going like that, generation after generation, and over a long period of time, what you have is the kind of variation in animal, plant, and other species that we observe on Earth.
Perfeito. Então, o Máximo vai trazer a apresentação em duas etapas. A primeira delas, que nós estamos vendo aqui, trata da ciência da evolução, a segunda da pseudociência. E daí a gente vai discutir, o Máximo discute aspectos da teoria básica da biologia evolutiva, da evolução por seleção natural, tal qual foi proposta por Darwin, que está à nossa esquerda, e Wallace à direita, que envolve variação de organismos. Essa variação, ela é, pelo menos em grande medida, herdável, e a seleção atua sobre essa variação. Então, a gente tem organismos diferentes em uma população e a natureza acaba selecionando aqueles que têm uma característica específica que é favorável para a sobrevivência e reprodução num dado momento. Máximo, please.
Now, Darwin and Wallace presented their ideas in 1858. Several decades later, biologists started improving on the original idea between the 1900s, after the rediscovery of Mendel's work and therefore the birth of modern genetics, and into the 1930s and 40s, we had a number of improvements. And fundamentally, what is called the modern synthesis, that is the standard theory of evolution as it is taught still today in most textbooks, has 5 components instead of the 3 that I mentioned earlier. Right? So there is mutation. We now know that mutations in the genetic material, the DNA, is what causes the heritable variation that Darwin had observed but did not know where it was coming from. we have something called gene flow. That is, we know that populations and individuals move from one place to another, and therefore they carry, of course, with them their genes. So another factor that contributes to variation of organisms on the planet is the fact that there is migration. A third factor is non-random mating, meaning that, as you might have observed with human beings, people don't mate at random, right? They have choices. They make choices, and therefore, depending on the patterns of these choices, different sets of genes get transmitted from one generation to another. The fourth factor that we think shapes evolution is called genetic drift. This is the idea that in very small populations, you can see the picture, the image shows two different populations of birds. The one on the right is much smaller than the one on the left. If a population is very small, what will happen is that there will be statistical fluctuations in the frequency of the genes that have nothing to do with mutations, gene flow, non-random mating, or natural selection. They just happen by random. It's like tossing a coin. That increases the variation, however, the differences between different populations, just because of statistical fluctuations. And then the fifth factor is, of course, the big one that Darwin and Wallace had already described, and that's natural selection. So these are the 5 factors that most modern evolutionary biologists think account for the variation and evolution of life on Earth. A little bit more complicated of a picture compared to what Darwin and Wallace originally proposed.
Depois de 1858, quando Darwin publicou A Origem das Espécies, havia aqueles 3 elementos que o Pilote citou há pouco. A síntese moderna da biologia evolutiva, então, com a entrada da genética, né, dos estudos da genética a partir de Mendel, então, introduziram outros 5 elementos que estão aqui nesse slide: a mutação genética, que é a origem da variação, pelo menos uma das fontes de variação, fluxo genético, acasalamento, que não é ao acaso, né, como o Máximo comentou, alguns organismos eles selecionam parceiros, a deriva genética, que envolve, enfim, flutuações aleatórias de genes a uma população, e a seleção natural em si. Então, o panorama que o Darwin desenhou quando publicou a sua obra contemplava aqueles 3 elementos que a gente viu há pouco, que são a variação, hereditariedade e a seleção. Os avanços da genética, o conhecimento da genética fizeram, enfim, que nós tenhamos ainda uma visão mais complexa de como a evolução acontece, que é a síntese moderna, que ela continua sendo, inclusive, ensinada hoje.
Now, scientific theories keep evolving, however, over time, right? So we started out with the original version of evolution, 1858. Then we got to the modern synthesis in the 1920s to the 1940s. It's not that biologists stopped there. The current version of evolutionary theory is still being studied and still being written. It's not finalized. It's at times referred to as the extended synthesis. It is currently ongoing. And as the term implies, as the terminology implies, it's supposed to be a further extension of the original Darwinism and then of the modern synthesis of the 1930 and 40. In fact, you can see in this diagram that the oval, the ellipse in the middle, corresponds to the 3 original factors that Darwin and Wallace proposed as shaping the evolution of living organisms. The intermediate ellipses include the factors that the modern synthesis thinks are responsible for evolution. And then now you see an additional ellipsis outside, the bigger of them all. And this includes a number of other biological phenomena that have been discovered in the meantime. I will not mention all of them, but for instance, important are at the bottom the notion of multi-level selection. This is the idea that selection doesn't operate just on organisms, but at different levels, all the way down to directly on genes, to possibly populations, and maybe even at the level of species. The notion of epigenetic inheritance, this is the idea now empirically confirmed that genes are not the only thing that is transmitted from one generation to another. There is a lot of other material, there is a lot of other substances that contribute to heredity, and they were previously unknown. And certainly unknown in the time of Darwin and Wallace. And then the last one that I want to briefly mention is the notion of niche construction. This is the idea that, in fact, even bits and pieces of the environment are inherited, in a sense, from one generation to another, and therefore they are part of the evolutionary process. Think of the most obvious example, the most famous example is the dams that are built by beavers. Right, beavers build dams in a certain way, and the construction of those dams is actually part of what the next generation inherits. So it's not just the genes, it's not just epigenetic factors, it's even bits and pieces of the environment that gets inherited from one place to another. But what I want to point out is that this sequence of three versions of evolutionary theory are not in contradiction to each other. One builds on top of the other, as it often happens in the history of science.
Perfeito. Então, o Pilote destaca que há hoje uma discussão que ainda acontece, ainda está em desenvolvimento, da chamada síntese estendida da evolução, que ela envolve, como a gente vê no elemento central da imagem, os três pontos que Darwin e Wallace haviam já destacado quando desenvolveram a ideia de evolução. Também a gente tem os elementos da síntese moderna, e mais à direita os elementos, então, da síntese estendida, dos quais o Máximo destaca três. De baixo para cima, os que são destacados em vermelho, a seleção multinível, quer dizer, a seleção natural, ela não opera exatamente em um único nível, ela não seleciona apenas, por exemplo, genes, ou apenas organismos, ou grupos, por exemplo, ela opera em diferentes níveis de seleção. A herança epigenética também, e que tem sido discutida bastante recentemente, e o que se chama de construção de nicho, que são elementos, por exemplo, ambientais, que de alguma forma são herdados por gerações de animais. O exemplo mais famoso disso são as represas, os diques que os castores fazem. Então, os castores constroem os seus diques em represas, acabam modificando o ambiente no qual eles vivem, e de certa maneira os castores das gerações que se sucedem, que vêm, eles acabam herdando não apenas os genes dos seus ancestrais, mas também ambientes modificados por eles.
Okay, now we're going to switch at this point from the history of evolution to the history of anti-evolution, so to speak. So we're going to go and take a look at the different proposals that have been put forth as alternative to evolution, which, however, now most scientists consider to be a kind of pseudoscience. So here's let me see if I can advance it. There it is. Here's a nice little summary slide that it's complicated. I'm not going to go through all of the details, but basically what you see on the diagonal is a series of alternative theories that are supposed to be alternative to evolution. And the ones that are on the upper part of the diagram actually assume that the Earth is very young, only thousands of years old, which of course is in contradiction with everything that we know from geology, biology, and physics. The ones on the bottom, in the second half of the slide, actually admit that the Earth is old, but they reject for some reason the notion of evolution. So, for instance, just to give you some example, at one extreme you might find flat Earthism. This is the notion that not only evolution doesn't happen, not only the Earth is only a few thousand years old, but in fact it's flat. It's not even a spheroid. If you go toward the middle, you find young Earth creationists. This is essentially biblical-based interpretation of the history of life on Earth. This is the notion that the Earth is only about 6,000 years old, and that God created living organisms essentially as they are now. When you move a little bit further down, you'll find things like intelligent design, about which I'm going to talk a bit more in detail in the next few slides. This is the idea that, yes, okay, the Earth is in fact old, it's probably billions of years old, and evolution does it happen, but only up to a point. It is guided by some kind of intelligence and so on and so forth. And then all the way down here, you find what is sometimes referred to as materialist evolution, which is basically what most scientists agree actually happened. That is, evolution is a natural process. There is no intelligence behind it. It's all about material processes and physical, biological processes.
Então aqui o Máximo vai mudar a conversa da ciência para a pseudociência, das supostas alternativas à evolução. E aqui tem basicamente duas que envolvem o que a gente pode chamar de terra jovem e terra antiga, que são propostas, enfim, de ideias alternativas. As mais conhecidas por nós, né, que o Máximo citou o terraplanismo, por exemplo, o criacionismo da Terra jovem, que é a interpretação literal da Bíblia de que a Terra foi criada há poucos milhares de anos, e há outras pessoas que apregoam ideias alternativas, ou supostamente alternativas à evolução, que consideram que a Terra, de fato, é antiga, mas que há, por exemplo, algo inteligente que a criou, que aí vem o design inteligente do qual o Máximo vai, ou sobre o qual o Máximo vai falar em detalhe em breve.
Now, let's start, therefore, taking a closer look at intelligent design. The most famous version of the idea of intelligent design probably comes from William Paley, who was a natural theologian who lived and operated at the beginning of the 19th century, and to which, in fact, Darwin directly responds in The Origin of Species. And he's famous for this argument. He says, if you were to walk on a beach, and look at the image on the right, and then all of a sudden, instead of just pebbles and sand and stuff like that, you find a watch. Surely you'll be startled. Surely you'll be asking yourself, where does this come from? Who put it there? Who made it? In other words, you immediately realize that this is a design thing. It's an intelligently designed thing. It couldn't possibly be the result of a natural process. And Paley suggested that biological structures such as the human eye, for instance, are of the same kind, that essentially they're the biological equivalent of a watch, and therefore, of course, they have to be intelligently designed. This naturally was before Darwin and Wallace proposed their theory of natural selection. So we cannot blame, actually, Paley for suggesting these kind of ideas. It was perfectly reasonable in his time to think that that was a reasonable understanding of biological complexity. It just became much less reasonable once we actually had a mechanism in the specific case, natural selection, mutations and natural selections, that actually can create complex structures such as the human eye, and we'll talk about this a little bit more in a minute.
Então, talvez o argumento mais conhecido a favor do design inteligente é o proposto por William Paley, que é do relojoeiro. Ele propôs uma história na qual imagine que alguém caminha pela praia e encontra um relógio, junto com areia, com as pedras no chão. A pessoa vai encontrar o relógio e vai observar a complexidade do aparelho e vai entender que alguém criou aquilo, ou uma mente inteligente criou aquilo. E o Paley levou o argumento, então, para estruturas biológicas, como, por exemplo, o olho, especialmente estruturas complexas. O Máximo destaca que quando o Paley fez essa analogia, lançou essa ideia, isso foi antes de Darwin e Wallace. Então, de certa forma, era possível compreender o porquê as pessoas pensavam dessa forma. Hoje a gente entende de que forma a seleção natural, né, opera para, de certa maneira, produzir ou fazer com que coisas complexas ocorram na natureza.
Now, I just said that Paley was justified in proposing his theories because he wrote before Darwin. But in fact, that's true only up to a point. In fact, a few decades before Paley, there was this other fellow, David Hume, who was a Scottish philosopher and a member of the part of the Enlightenment, who had actually preemptively attacked a version of intelligent design. And he had pointed out that the whole idea of intelligent design actually suffers from a number of problems. We're not going to go and have time to go through all 6 of the objections that Hume raised, but I want to point out a couple. If people are interested, they can take a picture of the slide to take a look at the whole thing. But I wanted to point out a couple in particular. First of all, Hume said the analogy between the universe and a human artifact is actually fairly weak. It's like, yes, we do know that, of course, if we see a watch, we wonder who made the watch, because we know about watches and we know that they're made by people. But we don't know about universes. So you cannot make the analogy with an entire universe, because that is exactly the question. How did the universe come about? To say that it must be something like the watch is kind of begging the question in philosophical terms. That is, you're sort of assuming an intelligent answer before you can actually establish it. Another objection, that's number 5 down there in the list, is that the analogy between a human and divine mind, Hume pointed out, is clearly anthropomorphic. In other words, People who think that they can reason like human beings and understand how God would work, they're kind of presumptuous, right? They're using the human mind as a yardstick to understand the mind of God. It's like Hume said, come on, this seems a little bit unwarranted. And of course, the other thing that he pointed out, the similar point that he made, which is the last one in the slide, is that this whole idea is the result of, the idea of intelligent design is the result of anthropomorphic thinking. That is, we project on God human attributes, but we only do it partially and only when it's convenient for us, because if we actually really did think of God as the equivalent of a human designer, what do we know about human designers? We know that there is more than one, for one thing. Usually people, there's more than one person who does design things. We know that they're mortal, they die. And we know that they're finite, meaning that they're, human beings, human designers are not capable of infinite infinite powers. So clearly those are all these analogies with God, at least with the God that is understood as is understood by the Christians. And so since these are all these analogies, what makes these people think that an intelligent design, a human intelligent design, is a good way of thinking about these problems?
Bom, algumas objeções haviam sido trazidas à tona por David Hume, um filósofo, e essas são as objeções que o Máximo nos destaca aqui. Então, o argumento principal é que a analogia entre o universo e artefatos humanos ela é frágil, especialmente agora que a gente conhece a evolução, e também essa analogia entre a mente humana e a mente divina ela é claramente antropomórfica, quer dizer, nós estamos introjetando características humanas em um ser divino, enfim, divindade, atribuindo elementos e comportamentos, intenções, finalidades humanas ao divino. E também, Máximo destaca esse último elemento, que o designer humano, as pessoas que falam, que defendem o design inteligente, elas costumam atribuir só coisas boas ao designer, né, ao projetor, mas esquecem que projetores humanos, por exemplo, também têm falhas, são falíveis, são mortais. Então, há sérias objeções contra a ideia de que há um designer que produz o universo, as coisas vivas nele.
Now, this is the 1700s and 1800s. What about now? So let's take a quick look at two major ways of thinking of intelligent design in contemporary times, so in the 21st century. The first person here that I want to bring up is a guy named William Dembski, who is a modern proponent of intelligent design. And his objection to evolution is that modern science has eliminated one of the famous four causes of natural processes that Aristotle considered. Now, so in order to understand what this objection is actually about, I need to tell you a little bit about the four causes of Aristotle. You can go ahead, because there is another slide.
Certo. Então, o Máximo comenta que esse é um dos proponentes. Aquilo que nós vimos do William Paley, obviamente, em séculos passados, mas nós temos proponentes do design inteligente no século XX. E um deles é William Dembski, que ele argumenta que a ciência moderna eliminou as causas últimas de Aristóteles, sobre as quais o Máximo vai falar agora.
So this is a statue of Aristotle, which we can use to understand the four causes. So basically Aristotle said, look, everything has a number of causes, in particular 4 different kinds of causes. And so we can understand the origin of pretty much anything we're curious about by thinking in terms of those 4 causes. For instance, if I were to ask, what are the causes of this statue of Aristotle himself, right? Well, there are 4, as I said. Material cause, that's the answer to the question, what is it made of? Let's say, for instance, it's made of marble or bronze. In this case, it looks like marble. Then there is an efficient cause. So what or who made the statue? In this case, presumably a sculptor that was contracted by the local government in Stagira, Macedonia, which is where Aristotle was born, to actually make the statue. A third kind of question we can ask concerns the third cause, and that's the formal cause. How is it arranged? That is, what does it look like? Well, it looks like we think it looks like Aristotle, right? So it's basically made in order to look like a human being that was that was alive 23 centuries ago. And then finally, the last question we can ask is, what is its purpose? That's the so-called final cause. That's the one that William Dembski is complaining about. And the final cause in this case is, well, the government of Stagira and Macedonia wanted to honor one of his most illustrious sons, and that's why they commissioned the statue, right? Now, what Bill Dembski is saying is that modern science still addresses the first three causes. What is it made of? What is something made of? Who or what made it, and how it is put together. But it doesn't really address the last cause, which is, what is the purpose of this thing? And he thinks this is a deficiency in modern science. Now, he's half right and half wrong. He's right that modern science has, in fact, essentially eliminated the final cause. We do not ask the purpose of things like the human eye or living organisms or mountains or planets or anything like that. We only ask the other three questions. But the reason for that is because the theory of natural selection has, in fact, eliminated the need for a final cause. What we know now is that things that look like they have a purpose, such as the human eye, the human eye is for seeing. Yes, it is, but it is the result of a natural process, and therefore there is no purpose in the natural process. The natural process simply is a series of events. It's a dynamic set of processes that simply happens according to certain laws of nature, but it doesn't actually have a purpose, meaning that there is no intelligence behind it.
Bom, essas são então as 4 causas de Aristóteles: a causa material, a causa eficiente, a causa formal. Então, considerando, por exemplo, uma estátua como essa que o Máximo nos mostra aqui, a gente pode perguntar, por exemplo, do que ela é feita, quem ou o que fez ela e como ela está organizada. Aí nós chegamos na causa final, que é qual é o propósito, para que ela é feita. E, de acordo com o Dembski, essa é um dos problemas com a ciência moderna da evolução, porque a ciência ela eliminou a causa final. Então, a gente não pergunta, a ciência entende, a ciência evolutiva em especial, que as coisas são feitas como, por exemplo, o olho, não pelo propósito, para o propósito de fazer com que um animal consiga enxergar. Mas o olho, enfim, é um processo, é uma estrutura que deriva de processos naturais, enfim, que faz com que os seus possuidores possam enxergar. Mas, na verdade, não há uma causa, não há uma causa final, não há um propósito na elaboração ou na formação, na criação de uma estrutura, como, por exemplo, o olho humano.
So that's Dembski. The second big objection, the second big modern supporter of intelligent design is a biochemist, a guy named Michael Behe, who is at Lehigh University in Pennsylvania. At least the last time I checked. He probably is retired at this point. Now, Behe says that biological structures, again, like the human eye, are just too complex for being the result of a natural process. He calls this irreducible complexity. That is, these are things that cannot be reduced to simple building blocks and therefore cannot be explained by natural processes. In other words, Behe goes so far, in fact, both Dembski and Behe go so far as to admit that natural selection is a real thing. It's an actual process, natural process. It does explain certain aspects of biological variation, but not all. The more complex structures, such as the human eye, according to Behe, are still irreducibly complex. They're just obviously still the result of design. They cannot possibly be the result of natural processes.
Outro proponente do design inteligente contemporâneo é o Michael Behe, que é um professor de bioquímica, e ele é um dos autores da ideia da complexidade irredutível, na qual ele argumenta que para que uma estrutura complexa, como o olho, por exemplo, possa funcionar, é necessário que todas as estruturas estejam prontas e funcionando dentro desse órgão, por exemplo, e não que e por isso seria difícil que essa estrutura fosse formada ao longo de um processo evolutivo que demora gerações e gerações.
Now, Behe presents, instead of talking about the human eye, his favorite example is the bacterial flagellum. The bacterial flagellum is this little thing that allows several species of bacteria to move around in a liquid medium. And often Behe and his collaborators present images of the bacterial flagellum like the one you see on the left. The reason is because that kind of image, which is a cartoon, of course, is not an actual picture of a flagellum, really makes it look like it's a machine. Notice also, for instance, the little labels that these people put there, right? Universal joint, studs, stator, propeller, P-ring, S-ring. All of these are engineering terms, basically, and they give you the impression that they must be right, that this is obviously something intelligently designed because it looks too much like a machine. But in fact, a real flagellum under a microscope looks like the image on the right. The image is on the right, which of course look nothing like the one on the left. Yes, there is obviously a flagellum. There is a tube there, tubular structure. There are internal structures. The three circles that you see on the right are sections of the flagellum that are done at different levels, so that biologists can study the internal structure of the flagellum. But you can see that looks like a biological structure, not like an engineered thing. It's messy. It is complicated for sure, but it is messy. It's fluid. It changes all the time. It really is not a machine. It's got nothing to do with a engineered human type sort of design.
Normalmente, o Behe, ele traz como exemplo não o olho humano, mas a estrutura da bactéria, do flagelo da bactéria, que faz com que as bactérias consigam se mover. E a imagem esquerda é uma imagem que o Behe mostra que, de fato, para quem olha para ela, parece uma estrutura de engenharia, com peças, inclusive os termos que ele dá para as estruturas do flagelo da bactéria soam como junta universal, coisas assim que são termos de engenharia, parece algo de fato criado. Mas se a gente olhar para a imagem à direita, que é a imagem de um flagelo sob o microscópio, a gente vai ver que é uma estrutura muito mais bagunçada, muito mais complicada do que aquela mostrada perfeitamente, ou que parece perfeitamente ajustada, como o Behe nos faz acreditar ser.
Not only that, he claims that there is no way that something like the bacterial flagellum could have evolved gradually, one little piece at a time, which is what the theory of evolution, of course, predicts. But that's simply false. What you're looking at here is a phylogenetic diagram of many species of bacteria, and the diagram on the right shows you both different pictures of different flagella in different species. Also, those little squares that are either white or black, they show you certain features of the flagellum that are either present or absent in different species. And you can see that certain features evolve. Sometimes they evolve more than once. For instance, this thing over here happens over here and then over here, but then it disappears in other species, right? And then there are other characteristics that appear at some point in the phylogenetic tree, and then they stay throughout the rest of the evolution of that particular group of bacteria. So what you're looking at is exactly what you expect if the bacterial flagellum were a biological structure that evolved gradually over time. You can actually literally see the bits and pieces of these things working, being rearranged by natural selection over a period of time, and coming up with a variety of flagella that are available today to modern bacteria.
Então, o Behe sugere que não é possível que organismos evoluam ou estruturas evoluam gradualmente. Mas o Márcio argumenta que isso é algo que a gente sabe que não é verdadeiro. A evolução ela acontece de forma gradual. A gente, inclusive, tem exemplos das próprias bactérias, como a gente vê aqui nessa árvore filogenética, de bactérias que têm flagelos diferentes ou que são um pouco diferentes de uma espécie para outra, o que sugere que há, sim, uma mudança gradual, evolução gradual dessas estruturas, ao contrário do que, por exemplo, um defensor do design inteligente argumenta.
Now, two can play in the same game. That is, the intelligent design supporters are going to say things like, this is the bacterial flagellum or the eye are intelligently designed. Evolutionary biologists can also play the game in reverse. We can ask ourselves, so what would a biological organism look like if in fact it were intelligently designed, as opposed to being the result of a natural process? Now we can apply engineering optimization analysis to certain organisms or certain structures and try to see what it would look like if in fact they were intelligently designed. And the next slide is going to show you what a human being would look like if in fact we were intelligently designed. Not exactly what we actually have, right? We don't really look like that. But there are a lot of structures that are interesting. Like, for instance, if we were intelligently designed, first of all, we would be more curved, bent forward. And the reason for that is because the fact that we are completely erect, that we walk completely erect, is actually a major cause of damage to human beings. Our back starts hurting when we're in our 40s or 50s because of all these walking perfectly erect. If we walked like that, we wouldn't have that kind of problem. Or look at the knee, for example, just as a second example. Notice that this woman has the knee bent backwards instead of forward. That's because, again, this is much more flexible and it's less prone to problems like knee operations, replacing kneecap and stuff like that. So, and there are other examples. I mean, here, for instance, we would have an increased number of rib cages. We would have an increased number of rings or discs on the back, because that would eliminate problems such as I said, different kinds of pains that we actually incur into. So this is what we would look like if we were intelligently designed, and obviously we don't look like that.
Nós podemos fazer um exercício parecido com um designer e pensar, por exemplo, se nós fôssemos elaborar um organismo como o organismo de um ser humano, como nós faríamos isso. E aqui está uma imagem de como nós seríamos se nós fôssemos, de fato, desenhados de forma inteligente, né? Se nós fôssemos objetos ou uma consequência de um design inteligente. Então, muitas coisas seriam diferentes. A forma de caminhar, nós andaríamos provavelmente mais curvados, porque o andar ereto provoca problemas nas costas, por exemplo. Nossos joelhos também teriam uma estrutura diferente, evitando desgaste das articulações, por exemplo, dos próprios ossos do joelho. Vértebras mais grossas, enfim, nós teremos uma série de características que nós não temos hoje. Então, se nós pensássemos como um designer, muita coisa deveria mudar no organismo humano e de outros animais, enfim, organismos também.
Now, in the next few minutes, I want to broaden a little bit the horizon here. So we talked about evolution as a science. We're talking evolutionary theory as a scientific theory. We talked about different types of creationism, particularly intelligent design as an example of pseudoscience. I want to now zoom out a little bit and talk about pseudoscience more generally, what it is and why it fails. And then hopefully we'll have a few minutes for questions. So this is my general idea about what I call the landscape, the pseudoscience landscape. There is no sharp demarcation between science and pseudoscience. Philosophers have tried for many decades to figure out a single criterion or a small set of criteria that could differentiate science from pseudoscience. That doesn't seem to be one. What you're looking at is a complex landscape. The two axes are supposed to summarize the level of theoretical sophistication in a particular discipline on the horizontal axis, the level of empirical support for that discipline on the vertical axis. And at one extreme, you find on the upper right side, you find disciplines that are clearly scientific, like particle physics or evolutionary biology. They have a high theoretical content as well as a high level of empirical support. At the opposite extreme, you find clear pseudoscience. Astrology, intelligent design, HIV denialism, all that stuff has very little, if any, theoretical sophistication and definitely very little empirical evidence. But you can also see that there is a lot of stuff in between. The social sciences, for instance, like psychology, economics, and sociology, they're actually deficient or limited in terms of theoretical sophistication, but they have a pretty good amount of empirical evidence on their side. Things like the scientific study of history or evolutionary psychology, they're kind of in between. They have a little bit of theoretical basis. For instance, evolutionary psychology is essentially evolutionary biology applied to human behavior. So that sounds good from a theoretical perspective, but in terms of empirical evidence, there is relatively little, because it's difficult to study, the evolved behavior of human beings for a number of reasons that I don't have time to get into now. So the idea is that, therefore, there are extremes on this diagram that are easy enough to figure out, but then there is a lot of stuff in between where, with more time, it may be that some of these fields are going to shift definitely into the direction of a science, or they might shift definitely into the direction of a pseudoscience.
Bom, o Máximo agora, nessa parte final da apresentação, vai falar um pouquinho sobre a pseudociência e a comparação entre pseudociência com ciência. Uma das coisas a destacar é que não há um critério simples e único para separar a ciência de pseudociência. O que o Máximo apresenta aqui nesse gráfico, que é inclusive um material do capítulo de um livro que ele escreveu, é uma proposta de separar a ciência da pseudociência com base em nosso entendimento teórico de uma área e também no suporte empírico, quer dizer, o quanto trabalhos, enfim, evidências empíricas nos permitem aceitar os resultados daquela área como bons. Então, a gente tem, por exemplo, áreas, se a gente pegar o gráfico na extremidade da direita do eixo horizontal, a gente pegar, por exemplo, biologia evolutiva, né? Então tem um entendimento grande empírico, então a gente tem aí uns décadas ou séculos de pesquisa em biologia evolutiva e também temos um entendimento teórico muito bom. Então essa é uma ciência sólida, uma boa ciência. Mas, se nós pegarmos na parte à esquerda para baixo do gráfico, a gente vai ver então áreas que têm suporte empírico muito pobre e entendimento teórico pobre também. Essas, então, são áreas claramente pseudocientíficas. Aí, mais um destaque, a astrologia, o negacionismo do HIV, que é basicamente a alegação de que o HIV não tem relação com a AIDS, o design inteligente, entre outras. O que é interessante, há áreas que estão no meio do caminho. Então, a gente pensa, por exemplo, a biologia evolutiva, como o Máximo menciona, ela é, de certa maneira, associada a uma ciência forte, que é a psicologia evolutiva, perdão. Mas ela carece de um suporte empírico sólido. Então ela fica mais ou menos no meio do caminho aí. E outras áreas, como psicologia, economia, também tem um entendimento teórico fraco e conhecimento empírico melhor do que isso, então também. Então, nem toda ciência ela é sólida, igualmente sólida.
And I want to finish with a brief mention of 5 problems that I see whenever we talk about pseudoscience. I will just go through these a little bit quickly. We could have actually a whole hour about this to talk about these, but I wanted to give you a flavor of what I think are recurring problems with pseudoscience. The first problem is that pseudoscience thrives on bad logic. That is, if you read anything written by creationists, astrologers, ufologists, you name it, the logic on which these people use in order to present their arguments is really bad. I mean, a introductory level student in Logic 101 would probably pick out these stuff apart. And this is illustrated not with a real example, but from a cartoon that I find pretty funny. The penguin in question here says penguins are black and white, some old TV shows are black and white, therefore some penguins are old TV shows, which is an example of really bad logic. And because the conclusion does definitely not follow from the premises, and so the caption says, logic, it's another thing that penguins, and I would add creationists and pseudoscience purveyors are very bad at.
Há uma série de problemas com a pseudociência, e o Máximo comenta que nós poderíamos ficar aqui mais uma hora discutindo eles. Mas ele vai mencionar alguns. O primeiro é que a pseudociência ela se cria, ela se propaga com base em lógica ruim. Então aqui tem um exemplo, né, do pinguim, enfim, ele traz esse exemplo como uma maneira de ilustrar o problema. E o pinguim, então, está pensando, né, os pinguins são pretos e brancos, e alguns programas de TV antigos também são pretos e brancos. Assim, ou portanto, alguns pinguins são programas de TV antigos. Então, obviamente, a conclusão ela não é suportada pelas premissas, né? Mas assim acontece com muitas pseudociências, ufologia, astrologia, né? O design inteligente, entre outras.
A second problem is that pseudoscience simply does not deliver. I mean, what is making possible right now, for instance, for us to talk thousands of miles away electronically and have this kind of conversation is science, is the result of science. Creationism, ufology, astrology, they never delivered anything like this. So at the end of the day, the proof is in the pudding, as they say. That is, science delivers. Sure, scientists make mistakes. Sometimes we have to retrace our steps and try again. But broadly speaking, science delivers, pseudoscience does not. This is exemplified here by another cartoon. If you look at what the guy has written on the on the blackboard. In the middle, there's something that says, and then a miracle occurs. And the professor there says, well, I think you should be a little bit more explicit here on step 2, because, miracles, of course, are not the kind of things that you can invoke as explanation within a scientific context.
Bom, outra diferença da ciência e da pseudociência é que a pseudociência ela não entrega o que a ciência entrega, quer dizer, ela não é capaz de ou explicar coisas ou de apresentar produtos palpáveis, né? Então, a pseudociência também faz isso, ela é obviamente muito mais frágil, ela não avança como a ciência avança. Aqui também é um cartão, o professor está no meio do quadro e explicando, enfim, uma equação, e aí a frase, então um milagre aconteceu. Aí diz, bom, acho que você deveria ser um pouco mais explícito aqui nesse passo seguinte, porque a ciência ela não funciona dessa forma. Dizer que um milagre aconteceu não é evidência suficiente para que a gente possa saber, enfim, suportar uma determinada alegação.
A third issue with pseudoscience is that it is in fact a little too easy. I mean, we have to ask ourselves, why is it so many people buy into pseudoscientific notions like intelligent design, creationism, or astrology, and so on and so forth? Well, that's because they provide, as the cartoon says here, answers that are simple. They're wrong, but they're very simple. They're easy to understand, right? Oh, of course God created living organisms. That's much easier to understand than start talking about mutations and DNA and inheritance and natural selection and stuff like that, right? Oh, of course God created the universe. That's much easier than talking about quantum mechanics or general relativity and so on and so forth. But the reality is, unfortunately, the world is a complex place, and we cannot just afford to go for answers that are easy if in fact they're wrong.
Então, outro detalhe da pseudociência é que ela muitas vezes apresenta respostas fáceis demais. Aqui, essa imagem, this cartoon is also famous, Máximo, here in Brazil. We have like versions of that. A gente tem aqui no Brasil de respostas, enfim, simples, mas erradas. Como é que o universo foi criado? Como é que a vida foi criada? Alguém pode alegar, bom, Deus criou o universo, Deus criou a vida e pronto. É uma resposta simples, mas errada. Ou a gente pode optar por respostas complexas, mas corretas, ou em grande medida corretas, mostly wrong, perhaps, talvez em grande medida corretas na ciência. Então, muitas vezes a ciência ela traz respostas que são complexas, muitas vezes mais difíceis de se compreender, e essa também é uma das diferenças da pseudociência para a ciência, né? Respostas simples e muitas vezes desejáveis que são trazidas pela pseudociência, ou por pseudociências.
And I think there are two more, and these are the last two slides, two more problems that, or two more factors that complicate our discussions about science and pseudoscience. One is this notion that unfortunately our mainstream media have bought into for a while now, that we need to balance things. In some cases, this is a good idea. If there are two or more ideas, opinions about something, and they are in fact all viable or they can be debated by, absolutely, we should be in fact talking about it. But in some cases, especially when it comes to science and pseudoscience, there are no balanced ideas. One is clearly, correct or likely to be correct, and the other one is clearly not. So for instance, this cartoon says, the host of the show says, tonight we'll be talking to an astrophysicist about the solar system, and then to balance his views, we invited a member of the Flat Earth Society. Well, the Flat Earth Society is just not a credible alternative to modern astrophysics. And so this notion that we need to provide for equal time, let's say, to cuckoo ideas like the flat Earth is just misguided, and all it does is it confuses people, because if you see on television two people who both look like experts, who both are wearing a tie, and who both talk with using big words, but one of them is spouting nonsense, it's a little bit more difficult for you to figure out that is in fact nonsense, because he's being presented as legitimate.
Muitas vezes para o público é difícil separar o que é, enfim, pseudociência da ciência, porque a mídia ela traz uma ideia ruim, equivocada do balanço entre ideias ou entre especialistas. E aqui o cartoon mostra um exemplo bem interessante e engraçado disso, né? Um apresentador está mostrando os convidados do programa, aí então ele diz, hoje à noite nós vamos falar com um astrofísico sobre o sistema solar, e para balançar, né, para contrabalançar as visões dele, nós também convidamos um membro da Sociedade da Terra Plana, para então ter duas visões sobre o assunto, que é obviamente um problema, porque muitas vezes há questões como evolução, para a qual a gente não tem duas visões científicas, e outras questões também. E isso muitas vezes confunde o público, que entende que tanto faz você optar, ou que há muita incerteza com relação a algum assunto, quando na verdade, cientificamente, é algo já bem estabelecido, como evolução, por exemplo.
And then the last problem, this might come not as a surprise, is posed by social media. Right, social media is the phenomenon of the last 10 years. There's lots of good things about social media. You know, you can keep in touch with friends and loved ones across the world. You can find at your fingertips information about all sorts of stuff. Unfortunately, you can also find a lot of crap out there, and equally unfortunately, or perhaps even more unfortunately, too many people seem to be unable to discriminate between good sources and bad sources. This is a lack of critical thinking, essentially. Again, there is a cartoon here illustrating the point. On the left, you see a scientist who's done his work on complex mathematics, and the guy on the right says, some guy on Twitter just said you're wrong. And no normal person, you would think, would believe that sort of stuff, and you would be wrong. Millions of people make their judgments based on whatever some guy has said on Twitter or Facebook or one of the other social media, and that is, I think, problematic. This is something that we really need to have a discussion at a societal level, how to deal with misinformation, especially when it is rampant and difficult to control, such as on social media.
Então, um outro problema é que a pseudociência, ela se propaga através das mídias sociais, como, enfim, Twitter, Facebook e assim por diante. Aqui tem um exemplo, né? Um professor faz um cálculo, enfim, faz uma demonstração matemática de algo, e uma pessoa diz que não, alguém no Twitter disse que isso tá tudo errado. Então, a mídia social de certa maneira, as mídias sociais são um veículo também, apesar, como o Máximo destaca, de nós conseguirmos várias informações, enfim, relevantes, contatarmos pessoas próximas, amigos, familiares, há um problema com um fluxo de desinformação em mídias sociais também. E aí, entre essa desinformação, parte dessa desinformação está associada à pseudociência, a propagações, alegações, enfim, falsas sobre ciência, e muitas vezes absolutamente mal fundamentadas, né, e que muitas vezes faz as pessoas acreditarem que são credíveis, né, por pessoas, como exemplo do cara que viu um Twitter de alguém e por isso, enfim, renega ou não aceita, eventualmente, por exemplo, uma ideia científica bem estabelecida em troca de talvez um tweet, alguma mensagem que recebeu por WhatsApp, como é popular aqui no Brasil.
That's pretty much what I wanted to say. Guillermo was very nice initially at the beginning to present several of my books. These are the three where these topics are explored in detail. Denying Evolution is mostly about creationism and intelligent design. Nonsense on Stilts, it's more broadly about pseudoscience and different aspects of pseudoscience. And then the philosophy of pseudoscience is a little bit more technical. It's a collection by different authors that really dig in the details of different aspects of the pseudoscience problem. Thanks very much for your attention. We can take a few more minutes for one or two questions if you want.
Yeah, Massimo, first of all, thank you. Thank you very much. It was a pleasure to have you here, your ideas, and also I strongly recommend your books. It's a pity we don't have them in Brazilian editions so far, but I hope soon we can have those here in Brazil. Massimo, let me ask you about the experts. You mentioned, for example, fake experts, or how media tries to balance the views between experts. I think it's very difficult for even perhaps for scientists who are evaluating arguments that belong to other areas of science. I imagine, like, for lay people or for non-scientists, but how can we discern experts whom we can trust from people we cannot trust? Como é que a gente pode distinguir entre bons especialistas e pessoas às quais a gente não deve confiar?
That's a very good question. There actually is literature about this. Both philosophers and social scientists have looked at the issue of expertise and trust, because we're really talking about trust. So who can I trust? Which expert or alleged expert can I actually trust? And it turned out that there are some things we can do, and they're kind of commonsensical if you think about it. So let's say that you have to pick a mechanic because your car is broken. You're not a mechanic yourself. So you're not an expert. You had to go to a mechanic. Well, how do you evaluate that mechanic, right? So first of all, you want to check that the mechanic is really a mechanic, right? That it has actually, the kind of certification that a mechanic should have in his shop, and it's not just some random guy who claims to be a mechanic. You also look at the track record of this mechanic, right? Has he fixed the cars so far in the past? Has he been successful at fixing cars? Has he been successful in fixing your car in the past? If so, yes, you can trust him. And if not, you're going to look for somebody else. You can also ask, what is it that other people say about this guy, especially other mechanics, right? So is there a consensus among people that work in the same area that they say, oh yeah, this is a good guy, this is a guy that you can trust and you can rely on? And of course, all of this doesn't mean that the mechanic is going to be infallible. Sometimes it will not be able to fix your car, right? But there is a number of steps of sort of commonsensical that you can apply. Now, it's a little bit more difficult, of course, to do the same thing for somebody who claims to be an expert in physics or virology or anything else, or medicine or something like that. But it is essentially the same kind of steps. You look for the credentials that this person has. You look for the agreement among other experts that this person is reliable, and you look for the track record of the expert, right? In other words, unless you are an expert yourself, you're not going to engage directly with the subject matter, right? Unless you're a mechanic, you're not going to fix your car. You bring it to somebody. And the same goes for other experts. Unless you're a doctor, you're not going to, you're going to go to a doctor if you're sick. And the same goes, it's the same exact situation for a for science. If you're not a physicist or if you're not a biologist, why would you try to do your research, quote unquote? You wouldn't do it in any other field, so why would you do it in this case?
Mas você comenta que de fato pode ser complicado distinguir entre bons e maus especialistas, mas há algumas dicas, algumas sugestões. Verificar, por exemplo, ele faz uma analogia com o mecânico. Quando a gente está com o carro quebrado, a gente procura um serviço de um mecânico. Então, primeiro, verificar se de fato a pessoa é aquilo que ela afirma ser. Verificar se é um especialista na área, nesse caso, em conserto de carros. Verificar também o que a gente pode chamar de track record, entre outras coisas. O passado da pessoa e assim por diante. E também verificar a opinião de outras pessoas, para verificar se de fato esse mecânico é bom o suficiente. Máximo, it's here in Brazil 8:10, so it's time to go. É hora de nós finalizarmos, combinamos com o Máximo mais ou menos 1 hora. Thank you very much, Máximo, for being here. It was an honor, and I hope you can get back in another opportunity.
It was a pleasure. Thanks for having me. And yes, I'm looking forward to future occasions.
Thank you. E obrigado a todos que viram. Um abraço, boa noite, até mais. Máximo, thank you.
Bye-bye.